All right, we're talking about solving quadratic equations. It's not a difficult section. Um, as long as you know how to factor, you'll be fine with this section. So this was section 13.6. So we're solving quadratic equations. And so remember, a quadratic equation has this form. It's ax squared plus bx plus c equals 0. And you're going to notice that as you solve these quadratic equations, you want to put it in standard form. So everything on one side, what number do you want on the other side? 0. So remember, this is standard form. And you want 0 on the other side because what property are you going to be using when solving these quadratic equations? What's that property called? The zero factor property. The zero factor property. So you're going to solve by factoring using the zero factor property. Now remember, now when you factored polynomials before, sometimes they were prime. You couldn't factor. Same situation here. So in this section, though, they're all factorable. If they were not factorable, then you would have to use the quadratic formula, which you're going to learn at the end of the course, the quadratic formula. But the ones in this section are factorable. So you'll be able to solve these by factoring. And to do that, you're going to use the zero factor property. Remember, the zero factor property says this. If you have two or more factors whose product is 0, so if A times B is 0, then what does that say about either A or B? Then either A is 0 or B has to be 0. So one of them has to be 0, right? So if you have a product that's 0, then one of those factors has to be 0. And so we started out with something like number 14 on page 1006. It looks something like this. We have 9x plus 1 times 4x minus 3 is equal to 0. So if you notice what we have here, we have how many factors here? You guys sometimes think of these as factors. How many factors do you have here? 2. What's the first factor that you see?
9x plus 1.
Okay, good. 9x plus 1. What's the second factor that you see?
4x minus 3.
And what do you notice about their product?
0.
Equals 0. So according to the zero factor property, one of those factors has to be what? 0. So right away, I want you to notice is that first of all, is this a quadratic equation? Yes, because if you FOIL this, what's 9x times 4x? 36x squared. All right, so a quadratic equation has that square term. And that's its leading term, it's a square term. So, and it's already been factored for you, right? So it's been factored. So all you got to do now is just set each of those factors equal to 0. So you'd say 9x plus 1 equals 0, and then 4x minus 3 equals 0. So notice I went from a quadratic equation to 2. What kind of equations are these? Linear. Those are linear equations. So to solve the linear equations, you get x by itself. You bring the variables one side, constants to the other. So to solve that linear equation here, I'm going to subtract 1 from both sides. So I get 9x equal a what? So what does x equal? Divide both sides by 9. So what does x equal? Negative 1/9. Y'all agree? I kind of skipped a step there. I thought that at this point you knew that you'd have to divide both sides by 9. So negative 1/9, right? Over here, what does 4x equal? 3. So therefore, what does x equal? 3/4. Okay, so those are your two solutions. All right? So these quadratic equations are going to have two solutions. for us right now, they're going to be real solutions. There'll be two real solutions in this case. Okay, now let's look at 22 or 22. So in 22 we have this. We have x squared minus 5x plus 6 equals 0. And I want to solve this equation. What kind of equation is this? Quadratic. Because later on in another chapter, the type of equation determines how you're going to solve it. So this is the quadratic equation. The only way so far you know how to solve a quadratic equation is to solve it by what? Factoring. In order to solve this by factoring, it has to be in what form? Standard form. Is this in standard form? Meaning, is every term on the left in descending order and is 0 on the other side? Yes. So it's in standard form. So now all I got to do now is factor the left-hand side. So first of all, you always look for a GCF. The GCF here is what? 1. So we go directly to the two binomials. And don't forget, you got to say equals 0. So it's got to look this. Make sure you say this times this has to equal 0. So XX, what do you want to try for 6? What do you think is going to work? Okay, -3, -2. Now someone said 6, 1. Let's think about that for a moment. I'm going to put 6, 1. The last sign is positive, meaning these signs in here have to be the same, and they both have to be what? Negative. Is that going to work? No, because they're going to be a -7x. So that doesn't work. You wanted a -5x. So what's going to work instead? Yeah, so x minus 3 and x what? Minus 2. So that works because what's the outer? -2x. What's the inner? And when I add them up, I do get -5x. All right, so I factor. Once you factor, what's the next step? What property do I use now? Zero factor property. So I say each of those factors equal to 0. And these are easy to deal with. What's x? What are your solutions? And x equal 2. Okay, that's 22. Okay, let's look at, let's do number 28. 28. Okay. Now remember the directions say solve by factoring. You have to use factoring only. All right, so how are you going to do number 28? Now, first of all, you know what the answer is. So that's an easy one to say right away what the answer is. What number squared is 9? 3 and a -3, right? A -3 times a -3 is a what? Positive 9. So you know the solutions. There are two solutions. What are they? 3 and a -3. But you got to show the work. And direction says solve by factoring. So what is it you got to do first? Bring the 9 over. You got to put it in standard form. So I get x squared minus 9 equals 0. Okay? Once you have it in standard form, then you use what? Factoring. How do you factor x squared minus 9? What is that? Difference of two squares. So how do you factor x squared minus 9? X minus 3 times x plus 3. Okay, good. So once you factor, remember that's the difference of two squares, x squared minus 9. Once you factor that, then what do you do to each of those factors? 7 equals 0. So what I'm using a zero factor property. So I'm going to say x minus 3 equals 0. And what's the other one? So what are your solutions? Positive 3 and a -3. All right, so notice I went from quadratic to 2 linear to my solutions. Okay? Now, in another chapter, you're going to learn about the square root property. So, something like 28, unless they tell you what method to use, you could have taken the square root of both sides. But that's not what it said. It said solve this by factoring, so you have to solve by factoring. But you could have used the square root property in another chapter. That's another chapter, though. So we're going to talk about the square root property later on. All right? Okay, let's look at 26. You have x squared plus 15x equal 0. What kind of equation is this? Okay, is it in standard form? Yes. So what's the next step? Factor. How are you going to factor the left side? GCF. What is the GCF? X. Okay. So how are you going to factor the left side then? X times x plus 15. Okay. So in the previous problems, you were dealing with two binomials because you had a trinomial. Well, except for the difference of two squares. But the difference of two squares is two binomials. Here, in number 28, you had a GCF. The GCF is a monomial. What's the GCF here? I'm sorry, not 28, 26. GCF is x, a monomial. All right, so it's a monomial times a binomial. But same idea. What are your factors? I'm going to ask you what your factors are. What are the factors in this factor here? X is the first one. What's the other one? What do you do to each of those factors? All right, so tell me what you said equals 0. X is equal to 0. And what's the other factor? So notice I went from a quadratic to two linear. And you got to get x by itself. Notice, though, this one, x is already by itself. So you found one of your solutions. What's one of my solutions? 0. Here, what's the other solution? 15. Okay. So notice in number 26, you had a GCF other than 1. So you factor out the GCF. And that GCF is a factor. You set it equal to 0. Okay. Number 50. You have 9x squared plus 7x equal 2. 9x squared plus 7x equal 2. What kind of equation is this? Quadratic. And you want to solve these quadratic equations by what method? Factoring, which involves what property? Zero factor property. All right, but to solve this by factoring, you got to first of all write in what form? Standard form. So how are you going to write this? 9x squared plus 7x minus 2 equals 0. It's got to also put in descending order. Okay, what's the GCF?
1.
1. So now you're going to go to the two binomials. Okay, trial and error. Try something that works. Okay, what do we want to try for 9x squared?
3x.
3x and 3x. Okay. And for 2, there's only one possibility. 2 and 1. And since 3x are the same, since the first terms are the same, it doesn't matter where you put the 2. I'll put it here. And this has to be a 1. Okay, the last sign's negative. That means that these signs in here are different. One's positive, one's negative. All right. But the larger of the out and the inner takes the middle sign. So let's check and see what the outer is. What's the outer? What's the inner? Okay, now look at what we have. Yeah, so the 6x has to be positive. The 3x has to be what? But does that help me? No. So the 3x and 3x is not going to work. So what should I try? 1 and 9. Okay, so I go off to the side. Do the 9x and 1x instead. All right, now this time, there's only one possibility for 2, 2 and 1. Now, it is going to matter where I put the 2, but let's put the 2 here for right now, and then 1 here, and see if that's going to work. Again, the last sign's negative. One's positive, one's negative. Let's get the outer. What's the outer this time? 9. For right now, it's 9x, all right? The inner is 2x, so the 9x has to be positive. The 2x has to be negative. When I add them up, do I get that 7x? Yes. I do, right? So the order's correct. I just got to put the correct sign. So this has to be 9x minus 2, and then x plus 1. All right? Okay, so what are my two factors? 9x minus 2 is the first one. What's the other one? And what do we do to those two factors? Set them equal to 0. So 9x minus 2 equals 0. X plus 1 equals 0. So that implies that 9x equals a 2. So my solution is x equal 2 ninths. Over here, my solution is negative 1. Okay? So that's 50. Okay, 62. 62. All right, you have 9y equals 6y squared. 9y equals 6y squared. What kind of equation is this? Quadratic. The only way you know how to solve a quadratic equation is by factoring. They put in descending order. All right, now let me just say this. When you put in descending order, it is very helpful. If you go back to all the problems we've done, the leading term meaning the y squared or x squared term, the leading term had what kind of coefficient? In other words, positive and negative. Which one was it? Positive. So when you put this in standard form, do you want to bring the 6y squared to the left, or do you want to bring the 9y to the right? Because you want the squared term to have what kind of coefficient? Positive. All right. So when I rewrite this, I'm going to say 0 equals 6y squared minus 9y. Okay. Now I want you to realize this. So when we did all the others, where was the 0 located in all the other problems? On the right. Here it's on the left. It doesn't matter. So 0 equals 6y squared minus 9y is the same thing as saying 6y squared minus 9y equal what? 0. Does not matter. Okay. And then what's the next step? GCF. What's the GCF? Not just y. 3y. Now, you could make a mistake and say y. I'm going to do it both ways. All right, just show you what's going to happen, because now you got to understand the difference. There's a difference between just straight out factoring, and there's a difference between solving this equation. So on the first test, if I said factor, I want you to understand this. If I said factor, and all you did was factor out a y, that's not correct. You had to do what? Factor out a 3y. Okay? You have to factor out a 3y. That's factoring. Factor completely. You have to do the GCF. And so that would be what? 2y minus 3? Okay? That's what you would have given me. Here you're just solving the equation. Solving the equation. So someone said factor out a y, right? Okay. Let's do that just to see what happens. When I factor the y, what do I get? 6y minus 9 equals 0, correct? Remember, all I'm interested in is solving this equation. And I'm solving by factoring. So there's nothing wrong with what I just did. Right here, there's nothing wrong with what I just did. But if you had on test 1 said this, that's not correct. This is an expression, this is an equation. Okay? So when it just says factor, you got to factor completely. So you got to find the GCF. Here, you're just solving this. So you're going to solve this by factoring, and I'm factoring. I'm writing as a product. I took out a y. It's not the GCF. You understand that y is not the GCF, right? But I still took out a common factor. Now, what are my factors here? Y, and what's the other factor? 6y minus 9. So you said each of those is equal to 0. And you solve for y. Well, y is already by itself here, so there's one of my solutions. How do I solve this linear equation?
Plus 9.
Okay, so 6y equals 9. So y equals 9 divided by what?
9,
6 reduced is what?
3
3 halves. Okay? There are your solutions. You solved. You solved by factoring. You didn't factor completely, but it's still fine. You got to understand the difference between this and this. There's a difference between those two. You still follow the directions. This says solve. This says what? Factor. Now, if you had used a GCF, what's a GCF?
3y.
3y times 2y minus 3 equals 0. Now, remember we had one a while ago, not a while ago, but last week, where technically there are how many factors here?
2.
I'm going to read it out to you. 3 times y times 2y minus 3. So how many factors did I read out? 3. The first factor is a 3. The second factor is a y. The third factor is a 2y minus 3. But we tend to put the 3y as 1. So you can say 3y equals 0. And what's the other one?
2y minus 3 equals 0.
And how to get y by itself over here?
Divide plus 3.
Divide by 3. You divide. Because right now I'm multiplying by 3, right? So what's y? 0, which is what we got here. Over here, how do we get y by itself? Add 3 to both sides. So 2y equals 3. So therefore, what's y? 3 halves, which is what I got here. Okay? So when you solve, it doesn't matter if you factor completely in the solving process. But on your test 2 and test 3 in your final, there'll be some problems that are going to say factor, and there'll be some problems that are going to say solve. So just notice that when you factor, you got to factor completely. So it's kind of like if you had done the y here. Remember, one of the things in that flow chart, one of the last things we said is that are each of the factors prime? So can it do anything else to 6y minus 9? I can take out a what? A 3. Right.
So factoring it completely is solving it.
Factoring completely here, this is where I factored completely right here. I took out the GCF.
Okay.
If you're referring to this as solving here, so when you think of solving, you think of an equation. This is not an equation. You just want to factor this completely. So factoring completely in this particular case right here means you got to use the GCF. I solved the equation 2 different ways. One way is to use a GCF. One way is just to use a factor, a common factor. And they both worked. Here, if a student put this answer and another student put this answer, which one's correct? That one. Here, if a student solved this equation this way and another student solved the equation this way, which one's correct? They're both correct. Okay? They're both correct. You just got to understand the difference between the directions. Directions here said factor. The directions said here said solve. Okay? All right. Now, normally, though, if you're doing this correctly, you would solve by using GCF. So this is the more preferable answer. This is what I'm really looking for. But if you do this, it's no big deal. You just didn't use the GCF. Okay? All right, 64. All right, 64, you have 3x cubed minus 27x equals 0. Okay. Now, first of all, is this quadratic? Quadratic equation has what leading term? X to the second power. My leading term is x cubed. This is actually a cubic equation. This is cubic equation. Now you may say, well, the title of the section says solve quadratic equations. So why we have a cubic equation in this chapter when it says solve a quadratic equation? Well, because at some point there is a quadratic part to this. But it is not quadratic, it is cubic. It's not a quadratic because the leading term is x cubed here. What would you do? You would still do the same way. You're going to solve this cubic equation by factoring. So what are you going to do? Okay, 3x, the GCF, 3x. It is in standard form. It's in descending order. So you can take out 3x. Now, what you notice what's going to happen when you take out 3x? When you factor out the 3x, you get 3x times what? Minus 9. Now, you see the title of this chapter is Solve Quadratic Equations. If I cover the 3x, this is what? One of your factors is quadratic. But you got to solve this by factoring. So what else must you do to the x squared minus 9? Factor it. So you're going to say 3x times the two binomials. So that's where the quadratic part comes in. So how do you factor x squared minus 9?
X minus 3x plus 3.
Yep, difference of two squares. All right, now, you see that 3x? That's really 3 times x. So 3 is a factor, x is a factor. What are your other factors? X minus 3, what's the other factor? X plus 3. So there are really 4 factors, but we tend to put 3x as 1. So we're going to set 3 things equal to 0. 3x equals 0. What else? Equals 0, and what else? Yeah. And so notice I went from a cubic equation to 3 linear equations. In the others, I went from quadratic to linear, right? This is cubic to how many linear? 3. So if 3x equals 0, that means x has to be what? 0. If x minus 3 equals 0, that means x has to be 3. If x plus 3 equals 0, that means x has to be negative 3. So if you look at all the previous problems we did that were quadratic, how many solutions were there? 2. So one of the something you're going to learn in college algebra is that the degree dictates how many solutions there are. So here my degree is 3, the largest exponent is 3, so I'm going to have how many solutions? 3. Now it's going to turn out that there are situations where the solutions are identical, meaning it's a double root or a cubic root. They occur more than once. But here there are 3 distinct ones, right? They're different. They're actually 3 distinct solutions. So if this is a 4 right here, you'd probably have how many solutions? 4. Okay. So that was 64. 66. You have 2x squared plus 12x minus 1 equal 4 plus 3x. What kind of equation is this? Quadratic. Is it in standard form? No. So I got to bring the 4 and the 3x over. So let's do the 4 first. If I subtract 4 from both sides, like this, see what I'm doing? Lining my like terms. If I subtract 4, I'm going to get 2x squared plus 12x minus 5 equal 3x, right? And then the next thing to do is to do what to both sides? Subtract 3x. And so when I write this in standard form, I'm going to get 2x squared plus 9x minus 5 equal 0. Okay. Now what do? Factor. GCF is 1. So I go to the 2 binomials. There's only one, and this one's easy to factor because the 2x squared, there's only one possibility for 2, and there's only one possibility for 5. So 2x and x? For 5, it has to be 5 and 1. Where do we put the 5? The first one? And the 1 in the second? Now, you know it's not going to work, right? But let's go on with it. It's not going to work, but let's go on with it. The last sign's negative, means these signs in here have to be different. The larger of the outer and inner takes the middle sign. What's the outer? What's the inner? So that means 5x has to be positive, 2x has to be negative. And when I add them up, I get 3x. I wanted what? 9x. So the 5 does not go where it is. Where do I need to put the 5? In the second one, right? Okay, and the 1 in the first one. So again, the last sign's negative. So these signs in here are different. What's the outer? 10x. What's the inner? X. So that means 10x has to be positive, because that's the middle sign. And x has to be negative. And when I add them up, I do get 9x. So the order is correct. I'm just going to put the correct symbol. So it'll be 2x minus 1 or 2x plus 1? Minus 1, and then x plus 5. All right, so I factored it. And now I use the zero factor property. I set each one equal to 0. So I say 2x minus 1 equals 0. What's the other one? All right. So I'm going from a quadratic to 2 linear. So if 2x minus 1 equals 0, that means 2x has to equal 1, which means my solution is 1/2. Over here, x has to equal -5. So those are your two solutions. Okay? Any question at this point? Okay, let's see. All right, let's look at this one. Let's see if there's one in here. Okay, so write this one down. Where's this example? Okay, I have 3x minus 1 squared equal 0. 3x minus 1 squared equal 0. Okay, how are you going to write this?
3x minus 1, 3x minus 1.
Yep. It's already been factored, right? So my two factors are identical. Okay. Now, you understand this is quadratic, correct? Yes. And we talked about the fact a while ago that it's quadratic. How many solutions will I have? 2. I want you to notice something, though. What do you know about these two factors? They're the same. So all you got to do is just set one of them equal to 0. They're the same, right? So if I set both of them equal to 0, I want you to notice something. 3x equal 1. So what's my solution here? 1/3. 3x equal 1. What's my solution here? 1/3. They're identical. How many solutions did I get? 2, but they are identical. So there's only one distinct solution. So you're going to learn in another course, college algebra, that your solution, there's only one solution, x equals 1/3, but it's called a double root. We're just going to say x equals 1/3 is your solution. Just know that in a future course, it's going to be it's called a double root because it occurred how many times? Twice. And the root means solution. The word root means the same thing as solution. Okay? All right. Okay, so there's only one other thing that you're going to see in my math lab. Now, the 2 worksheets you're going to get right here, you have enough here to do them, the 2 worksheets. But in my math lab, you're going to see something like this. Let me just go ahead and do this example. This is number 34. You have x times 4x minus 11 equal 3. All right. So x times 4x minus 11 equal 3. What kind of equation is this? It's quadratic. Okay? All right. So how would you approach this?
To make it not factored.
Okay. What'd you say? Move the 3 to the other side. Would any of you see how the left side looks factored or is factored?
Mm-hmm.
Would any of you say each of those factors is equal to 3?
No.
Do you think that would work? All right. So I'm not going to use this one because one of them is a fraction. If I do that, and I want to do a fraction. So let me do this one. Let me find one where just to show you that it's not going to work. But I just want to show you why. Just set each of those equal to 3.
Okay.
Is that going to give you the correct solutions? Yes. Yeah. The idea is to distribute first and then put it in standard form, which is what you referred to and what you referred to. That is correct. There are some students, though, that are not going to remember that and you're going to say each of those equals 0 because that's what we were doing, right? It was already factored and we set it equal to whatever number's on the other side, which is always what number? 0. But it doesn't. But this 0 factor property only works if what number's on the other side? 0. 0's on the other side. But you got to understand why it doesn't work. So let's look at I'm trying to find one that gives you some nice numbers. Okay, here we go. Let's try. This is gonna be 55. All right, 55. You have y minus 2 times y plus 3 equals 6. Okay? So you get so used to the fact that the left side looks factored, right? And you say, well, I'm going to use a 0 factor property. And you can say, I'm going to set each of those equal to 6 because that's what appears on the other side. So you're going to say y minus 2 equals 6, y plus 3 equals 6, right? Mm-hmm. And then you're going to say, well, I'm going to solve for y. So y would be what here? 8. Y would be what here? 3. But let's check. Let's check our solutions. So you go back to the original. Where we see the variable y, you plug in those numbers, correct? Okay. So let's do 8 first. Go back to the original now. That's where you must always go back to. So let's check y equal 8. So we have y minus 2, y plus 3 is equal to 6. So wherever we see a y, what do I plug in? 8. What's 8 minus 2? 6. What's 8 plus 3? 11. Is 6 times 11 equal to 6? No. So 8 is not a solution. Let's try 3. What's 3 minus 2? 1. What's 3 plus 3? Is 1 times 6 equal to 6? Yes. Whenever you do that, you don't get all of your solutions. You get how many of them? 1 only. You only get 1 solution. And how many should that be? 2. So that zero factor property only applies if what number's on the other side? 0. Okay? All right, so here's what we have to do. You've got to FOIL. See how this is 2 binomials? You got to FOIL this out first. So you understand that this does not work, right? Okay, so you got to FOIL this out. So when I FOIL this out, I get y squared. What's the outer? 3y. What's the inner? Minus 2y. And the last? Minus 6, right? Equal what? 6. Combine like terms. 3y and a negative 2y is y, correct? Minus 6 equals 6. So notice I get this quadratic equation. I got to put it in what form? Standard form. So that means I got to have 0 on the other side. So I'm going to subtract 6. So what's my equation? What's my expression on the left? Minus 12, right? Equal what? 0. Now I factor. And that will give you both your solutions.
Can you pull that down just on here? Yeah, I did y minus 3 plus 3.
Say again? Oh, you mean up here? That's y minus 2. All right. So y, and what's going to work is 3 and 2. And the 3 has to be positive. I'm sorry, 3 and 4, excuse me. Just check to see if you're paying attention.
Okay.
So 4 has to be positive, 3 has to be negative, right?
Yes.
All right. Now say each factor equals 0. That's where you use the zero factor property. Y minus 3 equals 0. Where did the 12 come from? A negative 6 and a negative 6? Negative 6 and a negative 6? You had a 9 because you remember you had y minus 3 here. That's why. Instead of y minus 2. All right. So y is 3. That's one of your solutions. What's the other? 4. And if you check when it works, go back to the original now. So let's check in the original. So we knew that which one worked? 3. We knew 3 worked, right? Now we're saying that negative 4 is the other solution. So let's check it. The original. What's negative 4 and a negative 2? Negative 6. What's a negative 4 and a positive 3? What's a negative 6 times a negative 1? Positive 6. All right, so you found your 2 solutions. So if you want your 2 solutions, you have to use what method? What property? Zero factor property, which means that what has to be on the other side? 0, not 6. So if 6 on the other side, you got to put it in standard form. So meaning you got to you got to multiply these 2 binomials out here. So that takes us back to the previous problem we had. Number 34. Now notice in number 55, you were multiplying 2 binomials. You had to use what method to do that? FOIL. Here, you're multiplying a monomial by a binomial. So you have to use what method? What property? Distributive property. So I get what here? Minus 11x equal 3. Okay, now let's put in descending order, in standard form. So what do I write?
4x squared minus 11x minus 3 equals 0.
Yep, and now you factor. A couple more steps and you're done. I think what's going to work is the 4x and x, not 2x and 2x. 4x and x works. So we're going to do 4x and x. 2x, 2x is not going to work. 4x and x is going to work. The 3 has to be in the second parentheses, and the 1 has to be in the first. The last sign's negative, means these signs are different, right?
Mm-hmm.
So do you see that the outer is a 12x, and the inner is just an x?
Mm-hmm.
And I need that middle sign to be negative, which means 12x has to be negative, and x has to be positive. And did you see that I do get a negative 11x when I add them? So it has to be 4x plus 1 and x minus 3. And you're almost done. So what factor does that set equal to 0? X minus 3. So what are your answers? Well, 4x equal what? Negative 1. So what's your solution? Okay. Over here, what's the other solution? X equals 3. All right, and that's it. So the two worksheets, you're not going to see one like, on a test, I'm not going to give you one like 34 and 55 because of the time it takes. But in my math lab, you are going to have that. I didn't put on a worksheet, although I could. Maybe on the next worksheet, I'll have one like this, although it's not going to be in the test, and it's not going to be in the final. The one of your finals are usually straightforward like the others we were doing.
So if you put it on the worksheet, we get a bonus if we get it right?
No.
Oh, come on.
No. All right. So, so I'm going to give you part A and B. Now, let me tell you where we're going with this. So, I cannot assign the My Math Lab on this yet because what they did was they combined 13.6 with 13.7. And that's what My Math Lab, they put the two together. And in 13.7, it's not difficult. It just involves, some of it involves word problems, which most students freak out with. But it's not a difficult section.
You realize you say that in every section, right?
I know, I do.
Just making sure you do
Can
that.
I
Okay.
see the page under that one?
So, so your test 2 stops up to what we did today. Your test 2. 13.6, except it's not going to be like 55.
So where did that middle Y go? On the very bottom? Right there.
I factored. I factored. You have to factor. The outer and the inner has to be that Y. You factoring that huh?
It goes Y1. Positive 1.
It's kind of like in test 1 when I asked you to factor, on test 1, when you were asked to factor y squared plus y minus 12. What'd you do? How'd you factor that? On test 1, how'd you factor this? Two binomials. Trial and error. FOIL.
And when you're complaining, you can't remember all the time because it's trial and error. It's not this.
No, it's not this one that I can't do. It's the one where there's a 3 on the very left, or 4 or 5 or something.
Yeah, but your question though is what happened to this y? Well, you're factoring, and so the out and the inner will give you that middle term. I don't know, but
You remember this.
yeah, just you got to make sure you go back and look at that.
You have the framework.
All right,
Drink a little harder than
look at it again. All right. Okay, so I'm going to give you. Okay, so we basically have 2 chapters left. We're at midterm right now. We have 2 chapters left. They're not difficult chapters. As long as you know how to factor, you'll be fine. But you got to know how to factor. All right.